Hello, everyone, and welcome to the Midwest Azure and M365 user group. I'm Brett Bossick, co-founder of Skylines Academy and board member of the user group. Today, I'd like to introduce you to David, and David is going to be going through the journey to securing AKS. So David, go ahead and take it away.
Hello, I'm very happy to be here. Thanks you for receiving me. So, as was said, I will talk to you about how to secure AKS, specifically how to use Azure Active Directory identity for pods, which is not that easy to do, but hopefully at the end of this presentation, I will have shared with you enough information so you are curious about that and you want to try it. Can I go on?
Yep, go ahead.
Okay, perfect. So the agenda for today, we'll do a rapid introduction about what are the potential needs of why we would want to use pod identity and the trouble that we have in using identity between different services in the cloud. I will introduce you to, well, I will summarize again for the most advanced, the basic concept of managed identity in Azure. We'll talk about why containers are not always helpful in this specific case, and then we'll talk about the solution, because if there is a problem, there is always a solution. And we will talk about the project pod identity for Azure Kubernetes service, and then we'll go through some demonstration stuff with installation and of the requirement and some use case. I have prepared a demonstration environment, and hopefully it will work well. Okay, let's go on then. So I was already introduced, so I will not extend myself on that. I'm a geek, I admit that. I'm still struggling with Kubernetes because this is a very complex topic for me. And usually when I have a success on achieving something, I want to share that. And that's typically what is the topic today. I struggled a lot to make it work. And today I'm sharing with you the result of what I did. A rapid introduction then. We want to secure AKS in the point of the pod, which is the atomic piece of Kubernetes, as you may know. We need to have an AKS Azure Active Directory integrated in the new way, meaning with managed identity. What we will do today is dive into the how to make it work. And since we need also to make it work, there will be obviously some prerequisites, and we will talk at length about that. Okay, so basics concept of managed identity in Azure. So this is some basic, but I need to put some context. Usually, what we have on an application standpoint, we have a front layer and, for example, a data layer, and the front usually need to access the data layer, and it does that with a connection string, and we have some authentication and some secret rotation. I guess this is not new for anyone. This secret obviously need to be rotated. Sorry, not yet. And obviously, at one point, managing this secret creates some question. Are we sure that the authentication stored on the front layer is secured? How do we manage the secret rotation? And well, that's not easy to do. And when we come in the cloud, do we have something that helps us to change that? Well, the answer is yes. We can take directly from the Azure documentation, the managed identity, which are, as you can see on the screen, we are attaching an identity to a service in Azure, which is the source, and by granting it some RBAC assignment, we are able to grant access without managing the credential to the service, which is very nice because it helps us both on the infrastructure side and on the developer side to minimize the impact of managing security credential, and that we like. I like schematic because it helps me to understand. So I'm trying here to represent how it's working. So as you can see in the middle, we have the little key with the Azure Active Directory representing the attachment. So the managed identity is indeed something that is present in Azure Active Directory. It is associated to resources that we present in red below, and we are granting access to other resources through an RBAC assignment. So that's for help us summarize and visualize how it works. we have two kind of system or manage identity. Sorry, we have the system assigned identity and the user assigned identity. The first one, the system assigned identity, is simply activating an option on manage identity aware service, for example, virtual machine or function or other services. As you can see on the screen on the top, we are just putting the status on, and then what we will get is an add-on in the directory, which will have the name of the service it is associated to. So as you can see on this screen, this is a virtual machine on which we are activating the identity. And then if we are querying the directory, we will find that identity and we'll be able to grant it some access. The second flavor of manage identity is the user assigned identity, and this one needs to be created beforehand, and then it is associated to a service. As you can see, well, it's partly cut on this screen. We have a user assigned table, and we can select add additional identity. The first one is nice because it is simple to activate and then to manage. The second one is a little less simple to manage because we need to create that beforehand, but on the other end, we can assign one or more user assigned identity to a service, and then on this identity assign different service, different access. Also, we may reuse a user assigned identity or on other service if we need to grant the same level of access. So on one end, the system assigned identity is very simple, but we don't have that much flexibility on the airbag assignment. Once it have an access, it's always the same access. On the other end, the user assigned identity is a little more flexible with the counterpart of having to manage a little more stuff. Whatever the flavor that you take on the other end, there is no password anymore to manage, never on your side. This is managed by Microsoft, and that's the good news. We don't have any password to maintain on the service that are using it. And from development standpoint, it means that there is never the need to have a password written in a hard way in the code, which is something that we unfortunately still have some time in our architecture. Okay, a little focus on why container may not be helping. Let's go back to some basics then. A container is basically an isolation of a runtime. And the good point is that it's removing dependency on the OS layer, which is very good. But this is kind of a black box also, because it's isolated. And since it's isolated from the OS, obviously, from a cloud platform perspective, if the OS is not able to see what's in a container, there's not that much chance that the cloud platform would be able to do that. Well, I will put some limitation on that. We do have some service native to the cloud called Azure Container Instance, which support managed identity, but it is a specific case because this is a container in a native way in Azure. A container on the other side, the bring your own container approach, is something that you bring in the cloud, and so it brings all its specificities of isolation, and you cannot manage easily identity on it. And it is even more true in Kubernetes, in which you have pod, which are hosting container inside, one or more, and then obviously we cannot manage use manage identity on the pod side. Well, or could we not? That's the topic of today. There is a project which is called Pod Identity for Azure Kubernetes service, and that's what we want to discuss about today. At first, it is an open source project, so I don't know if you had the opportunity to follow the news from Microsoft. It's been some time that I've seen the announcement of Pod Identity in development, and I've waited for that for some time. And at one point, I also came across the open source project of Pod Identity, which is mainly developed by Microsoft people, but for now is still in open source project, meaning it is not a fully integrated resources from Microsoft side, which means that you don't get support if you use it for now. it tends to change, just so you know. I've seen the announcement that it's now in preview on AKS, so you will be able to use the pod identity as an add-on on Kubernetes. And when it's not in preview anymore, it means that you will get both the support and less overhead of installation, as we will do together tonight. Okay, that being said, I've put that a few links. There is a GitHub repository, obviously, because this is an open source project. So as all the open source project that respect themselves, it is in GitHub. Also, there is an associated documentation on that, which is very thorough. And if you do some research on Google, you will find that there is already a lot of publication on that. Maybe not always up to date, but at least giving some matter to get started on that. On architecture and resources in Kubernetes standpoint, Azure Managed Identity at the pod level is composed of CRD resources, which are the custom resource definition for Kubernetes. And we have three, the three that are in the line below: Azure Identity, Azure Identity Binding, and the last one, Azure Assigned Identity. Then we have also architectural stuff in terms of Kubernetes object, a deployment and a daemon set that we will detail a little in the slides coming. So on the, again, a little schematic, because I like that. On the correspondence between Azure and Kubernetes, what is important to understand is that we need to make make a correspondence between two different control planes. We have on one side the Azure control plane, which is including Azure Active Directory, and on the other side we have a Kubernetes control plane. Azure Kubernetes being a managed service does not change the fact that the Kubernetes control plane is initially independent of the Azure control plane. So to make the correspondence, we have a few things to consider. I mentioned earlier that we can delegate the authentication of Kubernetes to Azure Active Directory. This is a prerequisite to make pod identity work. And to understand how pod identity work, we are getting back on the Azure control plane to what I talked about earlier about the user assigned managed identity, which is an object living only in Azure at the beginning. And with the custom resource definition, we are making a correspondence between the two control planes. So the user assigned identity has an equivalent in the Kubernetes control plane, which is the Azure identity. And this Azure identity will be assigned to the pod through an Azure identity binding, which will identify on the pod definition with a specific label called the AAD pod ID binding. This is something that is very frequent in Kubernetes, since everything on the pod level is not made to be resilient in time. It's evanescent. I'm not sure of the term in English. We don't attach directly the Azure identity with the pod, and we have a binding to make the correspondence. To make a comparison, this is the same with the role assignment in Kubernetes. We have a role definition or cluster role definition, depending on that. And when we want to assign that to some identity, we have a role binding. This is the same here, except that it is for Azure identity. We have an Azure identity, and to make it correspond, to attach it to a pod, we have an Azure identity binding. Okay. Okay, that's for the custom resource definition. And how does it work? I took this document, this picture from the documentation. As you can see, we can find the two additional objects that I mentioned earlier. We have the managed identity controller on top. Do you see my arrow moving over there?
Yeah, I can see it.
Yeah, perfect. So I mean that I can be interactive in my schema. For me, nice. So we have the deployment managed identity controller, which is talking to the Kubernetes API server, but also to Azure Resource Manager, and in doing so to Azure Active Directory. And we have on the worker side, on the node, we have the node managed identity daemon set as the name implies in Kubernetes wording, a daemon set means that we have a set of pods which are running on each node. So that means that if we have one or n node pool, we will have as many pod for node managed identity on each node that we have. And this node are here to intercept the pod requesting access to something in Azure through their identity. So you can see that there is a request as a managed system identity MSI, and it's talking. The node managed identity is talking to the Kubernetes API server because everything is going through the Kubernetes API server, and then the managed identity controller is receiving that at one point and is interacting with Azure Active Directory. Removing the Azure the Kubernetes control plane. If we take only the pod and what it needs to access on the Azure side, we have first a pod which is requesting access, which is managed identity to Azure Active Directory, but in between there is hidden behind that there is the managed identity controller. Azure Active Directory is answering back, providing a token to the pod, and then the pod is able to access to the service. And on the other end, because there is a corresponding role assignment in the Azure control plane, we can see with the 4 arrow that depending on the role assignment, we will get access or not. Okay. Okay, that's it for the theory, I guess. So now we need to focus on the preparation for the installation. So we are starting with an AKS cluster, obviously. As I mentioned, there is a RBAC enable because we should not do AKS without RBAC enable anyway. And we have Azure Active Directory integration. Okay. That being said, once the Azure Kubernetes server is provisioned, we need to understand what it needs to prepare the installation of pod identity. There are some requirements highly detailed in the documentation. And just so you know, I recommend you to read that thoroughly if you don't want to do the same as I did, which is trial and error and trying to find out where it's not working because you don't know and parsing some log from a few hours in the night. Anyway, okay, here I have a print screen, but instead of a print screen, I guess it's better if we are going directly in the environment. So I've got here a few things. I provision beforehand a Kubernetes cluster. I will switch between that also and an Azure Windows. Let me just open this Windows. Okay. Okay. So what do we have? Let's take that. We need to find on our Kubernetes cluster the identity that will be granted the correct access so that we can make work our pod identity. So we have here in this resource group, let me zoom that. We have a Kubernetes cluster, as you can see. And this Kubernetes cluster has in its property, it's working with a backend resource group that we can get here. And as you can see here, we have a few managed identity. You can see the little icon that I showed you earlier. And what we need to identify is which identity needs to get which authorization. And this one particularly is a managed identity, which is, as the name implies, attached to the agent pool. So typically, this is the identity that is used by Kubelet, the agent in the node pool, to get its authorization on Azure standpoint. So this identity we need to identify, and also going back in the Kubernetes, since we have used Azure Active Directory managed identity, we have a managed identity on this service, which we cannot get here except in the property maybe, which we need to address on we need to find out its ID so that we can grant it the proper authorization. So I did all my provisioning through a Terraform configuration, and as you can see here, I will leverage the output capability of Kubernetes, of Terraform, so I can get the information that I want. Okay, just to give you the example over there, let me reduce that and go back in my interactive screen. Just clear that. So what we have is a Terraform provisioning with some output. And if I just show you all my output, you will get a lot of things because I need to get a lot of information. Okay, as you can see here, I have a few information, and what I need to get is information regarding the Kubernetes control plane identity, which is what I call the Kubernetes control plane SI, because this is a system assigned identity. So I can get that like that. I could also use other tools such as Azure CLI or Azure PowerShell, but I find that much more comfortable for me to use that because everything I provision is done through Terraform, so leveraging the output for the information that I want is easier for me. Okay, so that I can I will need to be attentive with that, so I can get this identity and grant it the proper access. Next, I also need another identity, which is the kubelet identity, and if I look at that, I have that over there, so I'm able to get that. Oh. And here you can see that I get the information regarding the user assigned identity. It's written here, it is a user assigned identity, while on the other one it was written that the other one was a system assigned identity. Okay, that's why we have user assigned identity nothing, because it means that it is a system assigned identity. We have a client ID, an object ID, and also a resource ID in terms of Azure resources, and that is very important because we need that when we do our configuration later with the correspondence of the role. Okay. That being said, I already showed you that. We need a few roles on our identity. We need to make it sure that the kubelet identity is able to manage the node pool, so you can interact with it. So we need to assign it the virtual machine contributor, and we also need to be sure that it can manage identity. So we have another role, which is manage identity operator, and those two roles need to be assigned to kubelet, to the kubelet identity, and at some point also on the system assigned identity from the control plane. Just so you know, here you can see that I've written a very quite large scope in terms of airbag assignment, because the managed identity, depending on where they are created in a resource group, in a specified resource group, you need to identify in which resource group the managed identity that you will use or create it, so that you can assign the proper access on this identity. In my case, it was simple for me to assign a scope at the subscription level, but that's not necessarily what you may want to do. Okay, so that's the configuration that I use to assign the role. Again, if you get in the documentation, you will see that the proposed configuration is done through AZ-CLI. On my side, I consider that it was easier to centralize everything in the Terraform configuration, and that's how I did that. Okay, so apart from that, then we have the role assignment. And then we have the installation part. So let's switch back to the slide just a few seconds before moving back again to the demonstration. I did not reinvent the wheel, obviously. I had to rely on the documentation. And what I want to highlight, just so you know here, as you can see, I've written a specific Allo Network plugin in a red frame. Starting from the version 1.7 of pod identity, you cannot use pod identity by default with KubeNet. KubeNet, just to remind everyone, is one of the options that we have in terms of network configuration in Kubernetes. Either we use the Azure CNI, either we use KubeNet. Azure CNI has the much more capabilities, or at least at first, but it also has the disadvantage of consuming identity in the virtual network for each of your pod. If you have an environment in which the private IP is expensive because we don't have that much available range, you cannot request to have a very large CIDR range for your virtual network. You need to find a way to mask the pod IP that will be consumed. And KubeNet is one option to do that. Well, not the only option currently, actually, in Azure. On my side, I have a lot of clients who are not able to give a lot of IP for Azure environment. So KubeNet is the solution de facto to answer that. But since we need to use KubeNet, just so you know, if you want to install that, you need to specify either in the manifest, the YAML manifest for the pod identity installation, that you that you want to use the network plugin KubeNet. So this is something that you add in the definition in YAML, or if you are using Helm, you can also specify this specific parameter. Okay. So let's go back to the installation. I will just clear that. Oh, sorry. We said earlier that it was not easy if I did not hide the configuration. So I have already pre-configured my Kubernetes cluster. So just so you know, I will just get the config that I have, get context. As you can see, I have two Kubernetes clusters. I will switch to the second one. Because I want to do some installation in live. It's not fun, if not. But if we have some issue, we will switch back to the one that is already working. Okay, and now if I'm just getting the basic command to get the node, it should ask me to authenticate. No, it's not. So I have two running Kubernetes environment. Just to show you that nothing is installed yet. Oh no. I already installed everything on this one also. Oh. Sorry. Get context. Oh, sorry, I think I misunderstood something. Okay, anyway, let's just switch in the installation so that you can see anyway what we need to install. We have two files for the installation, huge file, so I will not parse that anyway. We have the capability to use the Helm chart for those who are much more familiar with Kubernetes. On my part, I must admit that I'm still considering myself a newbie in Kubernetes, so I'm not Helm comfortable yet. The first part is to install all the components of the pod identity, and the second part is to install another part, which is the exception. If you remember the schema, maybe I can switch back to this one just to be sure. Yes, this one. I mentioned that the node managed identity is intercepting the request from the pod for the identity. I also mentioned that we have other identity. Let's switch back on the Azure side. Property over there. And over there, I also mentioned that there are other managed identity that are used by Kubernetes. And if we don't specify the exception, we will break some feature of Kubernetes. So for example, this one is used by Kubernetes for the monitoring extension, and we don't want the node managed identity to intercept the call. So we are using this exception to be sure that it will not interact with the existing services. Okay. Okay. No, sorry about that. Okay. So let's go back to the configuration now. What I mentioned earlier is that we have two custom resource definition that we need to install. That's something that since I want to prepare that more easily, where is that? I use a specific module that I wrote for that, which allow me to create a Kubernetes, a user assigned identity, and then pre-populate the YAML file that I will use afterward in the configuration. Here you can see that I have some template. I also have somewhere else the template that are used for the pod identity afterward. So let's just put everything in action and let me show you how it's done. I will just run a plan. I have everything provisioned except this specific part, which is the UI user assigned identity. If I'm just doing a plan, I will create a new identity and also create the associated file. Okay, you can see that I have 9 resources that I will add, and I will create a new identity, also some secret. And as you can see, I'm leveraging the pod identity, the local file resources to create some file. And if you can see over there, it will create it will create the file with the definition that I want, so that it can make the correspondence between the identity that I create in Azure and then the object that I will provision in Kubernetes. Okay, so let's just run the apply. While it's doing its stuff, let's go back to our Kubernetes environment. So this one, let's check what we have currently. If you are going in the environment, you can see that this Kubernetes cluster does not get yet the pod identity installation. So we will install that afterward. But since my change for the context was not done correctly, I will reset my installation just in live. So just remove my kubeconfig. As a matter of fact, I don't need to do that. Kubernetes configuration, when you get your credential, is writing everything in a config file that you can see here. It is called the config in the kubeconfig. So I will remove this file, and now I will recreate the configuration so I can switch back to the configuration. It shows that I'm still not yet a specialist of Kubernetes. Anyway, so I need to get the credential from an AZ command, AZ account show. Okay. Okay, this is the proper configuration if I'm correct. So if I'm just listing my Kubernetes cluster, Oh, sorry, is it big enough? Do you need me to zoom maybe?
Yeah, if maybe you could zoom in a bit, it would be
Yeah,
helpful.
perfect. Let me just do that. I will use the proper. Okay. So yeah, I'm just preparing the authentication of my Kubernetes cluster. So as I showed you earlier, since I was not able to switch of context with my two Kubernetes cluster, I removed the configuration and I will create a new one. In terms of Azure, I need to be on the proper subscription. That's why I was checking with AZ that I am in the correct subscription, and then I'm listing in the next command the existing Kubernetes cluster that I have. Okay, so now that I've identified that, let me unzoom just to get my credential. I have another command. I will specify the name of my cluster, obviously, and its resource group. And now it has created me a new config file. As you can see, if I'm doing kubectl get no, this time it should ask me to authenticate because I have an Azure Active Directory authentication. So let's just show you that I'm authenticating on Azure. Okay, so it's asking me for a code that is over there. That's for the Azure ID authentication, the basic one. Okay, that's me. Perfect. And now it should answer me and give me the current existing node. Okay, so I'm connected on my Kubernetes cluster, and now if I'm getting the node with the command kubectl get node, let's write that correctly. You can see that I have two existing nodes, and I'm ready to interact with my Kubernetes environment. Okay. Here you can see that my provisioning is finished on this way, and you can see that I have a few additional files. I have one specific, well, no, this one I will talk about later. I have a user UI lab meetup2 YAML, which is a definition for my user assigned identity that I just created. And as you can see, it automatically fill in the required value. That's why I did that, because well, I'm a lazy guy. I don't want to look for the correct information if I can automate that. And then I have an identity over there, and with that I'm able to I'm able to create the proper object, but I'm not able to do it now because the pod identity is not installed yet. Let's just check that. Oh, let's just zoom in over there. Get pods. And as you can see, in the default namespace, I have nothing because nothing is installed. So let's install all of that. Copy paste. So here I'm just getting the file from that I showed you earlier, and I will create my configuration. I will now create my exception. Okay. If I'm checking again my pod, now I have the new pod that I mentioned earlier, and if I'm that I should get, if I'm getting the deployment, as you can see, I have the deployment that I mentioned earlier, which is the managed identity controller, and if I'm getting daemon set, I get this one. Okay, since I have only two nodes, I have only two pods in it. I could check the log just to be sure that everything is working correctly. Logs. I want the log since 300 seconds. It should be enough, and I can see that I have no error, which is nice. If I'm getting the same for the daemon set. I need to specify the name of the daemon site if it's not working. And I can see also that I have no error yet. Okay, no. Now what I want to do is prepare the use of my pod identity. So I will use those two files that I prepared earlier. Okay, let's do again kubectl apply. No. First one, and that's the second one. Okay, and now I should be able to get the two CRD resources that we mentioned earlier, which is the Azure Assigned Identity, the Azure Identity, and the Azure Identity Binding. So if I'm getting Azure Identity, I should get one. No. TL. Oh, so that's not the good name. Kind. I need to do get, sorry. And you can see that I have the identity that I was requesting, and if I'm getting the Azure Identity Binding, get also the one that I just created after earlier. What I don't have now is the Azure Identity assignment, which will not exist as long as I did not create any assignment for a pod. So that's what we want to do. I will show you a simple use case of using pod identity with an access to a key vault that we created earlier. So just switching back to no, not this one, to Azure side, you can see that in our resource group we do have a key vault. Okay, and if we check the access policy, you should see somewhere over there that yes, you can see that over there. Oh, sorry, it's not working. Okay, so sorry about that. You can see that there is the user assigned identity called lab meetup2, which is assigned to permission on the key vault. Okay, that's the identity that we will use, and to leverage that, we will use something called the CSI driver for secret store, which allows us to map secret store in Kubernetes on pod. Okay, so I have already prepared a file for that, but before being able to do that, I need to install the full configuration of the secret store. I have prepared also a file for that. Let's reduce that. Oh, maybe I can do that. Open in preview. Yeah, but this is much more readable, like that. Okay, I'm deploying a few things. I'm not explaining that much because this is another topic. As you can see, I took that from another documentation. There are some moving parts for that. Finish the installation. Then we just need to install the plugin so that the secret store provider for Kubernetes will know that it can use Kubernetes. It can use Azure Key Vault. Okay, let's clear that and switch back to that. Now that I've prepared all my prerequisites, I need to create something that will also make a correspondence between my key vault in Azure and the equivalent for as a secret store in Kubernetes, and that's a file that I also created at the step earlier when I applied my Terraform. This file is creating a Kubernetes key vault for my Kubernetes secret store, sorry, for my key vault that I mentioned that is called like that. Let's just switch back a few seconds to Azure to be sure. And as you can see, this is really the name of my key vault, so everything should be working fine afterward. Let's create that. Apply not F. No, it won't work because I forgot. Okay, it seems that it worked. And now we have a secret store that will allow me to create to match my identity with my pod. Let's go back to the pod definition. As you can see, I have prepared a demonstration pod. This pod specifically will mount a secret store that we just created with a provider class, which is the key vault. Okay, let's do that. And then afterward, we should be able to parse the key vault from our pod with a managed identity and without writing any error or password. So let's kubectl. Okay. If I'm doing kubectl get pod, I should see that the container is creating. It's taking some time. To be sure that there is no error, I will just do a describe and pod and the name of my pod, if I'm correct. Okay, there is no error written over there, which means that it's just taking some time. If I'm just going back to the log that I did earlier, as you can see, there is still no error, but you can see that there is a request for my pod. Maybe I should zoom that again. Look at that. Default Nginx secret store inline has been matched with another identity called default URI lab meetup 2. So we can see in the log that the pod identity infrastructure made the association between the managed identity and the pod, which seems to be good because that's what we want. Let's do again a get pod. The pod is ready. Nice. Let's get again in the definition. As you can see, I specified a volume with this path. So what I want to check now is what is in this module, in this volume. Sorry. So let's just do that to do some teasing. What we want to see is the secret. So exec the name of the pod. No. I just need the name of the pod. I just want to ls to be sure to list what is available in this volume, and I should get one answer. Okay, you can see that I get this answer. It means that there is one file mounted in this volume. If I switch back to my Azure environment and I'm switching back to my secret, I can see that I do have one secret which is called KVS test 01, which means that we have the good correspondence, which is a good sign. Let's move forward with the last manipulation of our demonstration. Let's do a cat, but this time of the secret store content, which is that. I forgot the one. Okay, and I get a terrible string, which is the secret that I get. And if everything is working fine, I should see in the key vault that this is the same value. And it looks like that's the same value, which means that we made it. We made the correspondence between our pod and the managed identity so that it can access a key vault. Okay, nice. Everything worked perfectly well. Let's switch back to the slide. We did have to use another moving part that we did not describe in length, which is the CSI driver. That's another topic, but it brings me to the conclusion, which is that we have a way now to associate user assigned identity in Azure Active Directory with pod. We still need to understand how it works, and as you may have guessed, it was not an easy work for me, but hopefully what I did helped you to understand that better. I also mentioned that support from Microsoft is coming because it is in preview as an add-on, so it will be much more easier to configure and probably with less kubectl command that I did tonight. Nevertheless, it will not remove the fact that you will need to understand what you do with this identity and how to use it with either your own development or with other solutions that are able to use it. For example, I'm currently doing some tests with the solution for backupping the environment in Kubernetes, which is called Velero, and this solution is pod identity aware. I guess that a lot of them will be more pod identity aware for Kubernetes in Azure deployment, and that we will be able to get more security and maybe one day achieve this journey that we started to secure AKS. And that's all for me. And then I have the traditional slide with any question.
Thank you, David. Great presentation. Does anybody have any remaining questions? Anybody? Okay, well, we're going to be posting this on YouTube, and I wanted to tell you all who joined today that you can you can have access to all Skylines Academy courses, so on-demand Azure and Microsoft 365 content. I'm going to just paste a coupon code into the chat here. Just give me one moment.
Just so you know, I've shared a Git repository specifically for all the code that I used for this demonstration, so I can share it with you by mail if you want. I also written, well, a kind of an article also in terms of in a specific GitHub repository, which re-explain everything of what I did today in live. So I will share that with you, so you can share it again to the community. I guess it might be useful if you want to try that out on your own.
Yeah, sure. So we will add the links that you send us to the YouTube video, and we can put them probably on the website as well. Yeah, if there's any other information you want to share with us and post as part of your video, that would be great. We also have a website I'm going to post in here for the user group, and you can see all of our upcoming sessions that are coming up in the next few weeks here. So everyone feel free to check them out. But otherwise, David, thank you so much. It was really
Thank you for having me.
Yeah. You're going to have a good one. Thanks all.
Thank you. See you. Bye.